Hello everyone, there's a few things we're going to fix in this video. This is the Atari adventure game, which is this little guy here, the Atari adventure game. We are going to set up the room renderer, which means we're going to have to figure out what happens when the player reaches the bounds of the screen. How do we react to that? Um, and so we're going to have to find out the screen size. We're going to have to figure out the room change, like I said, and then we're going to have to render those blocks on screen. And of course, all of that happens after the fade. Okay, I think the first thing I'm going to tackle is the wrap player on screen bounds. I'm going to add that in progress. I've started to add colors to this as well, just to know where I am. So the three topics that we did, or the three tasks that we did, these are for video 1, and then this one here is for video 2. So yeah, just a little bit of organization inside here. Let's put up our scripts. Actually, I'm going to create another script here. So I'm going to call this folder general. And I'm going to call this my usual thing, which is game controller, which is really a kind of world controller, but um, you know, in a general sense, that's what it is. It controls the environment. I mean, I guess environmental controller, whatever you want to call it. I'm terrible at. If you've been watching this channel for any length of time, then you'll notice that I do not know how to name things, and it is a weakness of mine. But there we have it. Okay, so inside here we've got scripts. We need our locomotion player, but we just need the game object. In fact, we probably just need the transform. So we're going to do public transform player, and then we're going to detect to see if they are outside the bounds of the screen. Now, I don't know the bounds of the screen just now, so what I'm going to do is I'm going to guess it, and I'm going to add those values to here, and I think, yeah, I think I'm going to say that's the top X and that's the bottom. Sorry, that's the top position there, and then down here's the bottom position. So I don't know the size just now, but I'm gonna guess it, and then we can change those values later on. So I'm gonna say public vector 2 top left, public vector 3 bottom right, and from there I think I can get everything I need. So let me just grab the player real quick, and inside the scene I can move the player to the X most value here and the Y most value there. So the top right is, what's that? Let's say that's 15, and that is negative 27, nearly negative 28. Let's call it negative 28. So negative 28, 15. Okay, so I'm going to create a game object here. So create empty, and I'm going to put it at 0, 0, 0, and I'm going to add their game controller component there. And then so for the top left, I am going to copy that there, which is negative 28, and what was the Y? Maybe like a sieve, 15. Okay, so that is 15. And then I'm going to guess this is the exact opposite of that. So I'm going to just drag that to be sure. I'm going to drag that down to about here. And you see that it's 27 minus 15. So that works out about right. So that is 28 minus 15. Sounds good. Okay. And then while we're at it, we'll just drag in the player here as well. So now we have a copy of the player transform. We could probably tidy this up. We can certainly tidy that up because that should be a vector 2. We could have added it as bounds as well. Actually, should we have it as bounds? Yeah, actually, let's have it as bounds. Screen bounds. Yeah, let's do screen bounds. Okay, so we're going to create that in there, and so it is 0, 0, 0, which is right, and then we extend it on our. Is there a way to see this? This view. Well, I guess we want to extend it to 56 on the X, and then 30 on the Y, and that way if the player leaves it, then they've left this space. I don't know why we can't see that. I don't think we need to worry about that just now. Okay, so I'm going to do 0, 0, and so now I'm going to check to see if the player is inside the bounds, and if they aren't, then we need to do something. So I'm going to say if screen bounds dot contains, and then we need to pass in the points. So that's going to be player dot position. If it doesn't contain that, I'm going to do print outside. Okay. All right. And then I'm going to press play. So the console is there, and then I'm going to move the player over to the right. I just picked up a sword already, and nothing, not a thing. Why are you not working? Transform. Player. So the player is now 28, and he's not inside there. That's how it works first time. Strange that. So what's the magic of this? I don't understand why this wouldn't work. Is inside is thread safe true. Contains vector 3 point. Okay, so screen bounds contains that, and 0, 0, 0. Okay. Am I using this wrong? If in doubt, find the script API. Okay, so represents blah 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 contains. Is the point contained inside the bounding box? If the point is passed, then it contains. Wait a minute. I know why. Because I need to do bounds 2D probably. No. No. Bounds contains will always. If bounds extents contains a negative value in any coordinate, then bounds contains will always return false. Okay, I don't have that. So start update. If collider bounds contains point. M collider. Should I do that then? Is that what I should do? I wonder. Let me think. Okay, well, it clearly doesn't like screen bounds. So let me change that to box collider 2D. And we'll change that to, yeah, it's fine. Don't sweat the small stuff there, compiler. Okay. So we go back to here, and then we have a, oh, wait, sorry, one sec. I want to add a box collider to 2D here. And I want to have it as a trigger. And the size, yeah, there we go, is going to be 56, and the height is going to be 30. We can make that bigger now. So now that we can do that, we can actually make this the full size of the screen. So that I think that's okay for 32, 31. I think that's okay for now. So now what we want to do is we want to check to see if it's inside or outside this bounds. So in this case, all we need to do is we have void on trigger exit 2D. And then we say if collision dot tag equals player, print they have left the screen. So now it's event driven, so we're not polling it. It's probably a better way to do this. So do we need to do anything else for this? I think that's us. So we shouldn't fire at all because you're currently inside there. So it's only when you move outside, boom, there you go, they've left the screen. Okay. And then we've left the screen. So you can see that the ticker is moving up here, this line here. So if you follow that line there, you can see that when you leave the screen, that ticker moves up, and so on. Okay, so we've done that part. So the next part is we need to move the player to the opposite side. So the way we can do that is we can say var. Now we need to know where they are relative to that position. So we don't want to. We just want to figure out on the X or the Y, depending on which way it's moved. So I think we can do. Well, let's see what we can do here. We can do var result equals vector3.diff vector3.dot and then the left hand side will be vector3.0 and then the right hand side will be collision.transform.position. Actually that would be 1, so that would be up, which is the up on the y-axis, and then this one here will be normalized. Okay, and then we want to print that out. Okay, let's see what this gets us. Okay, so I want to say when you leave, get 0. That's almost 1. That's almost -1. And that's -0. That's 1. Is this going to be 1 as well, though? 0.24. So in this way, we've got, oh, actually, that's 1, and that's -1. Okay, so for the up, that works well. Okay, so for up, that works. All right, okay. So for up, we've got this value here. So we can say if math absolute result is greater than 0, the player moved vertically off the screen. Okay, so the player moved vertically off the screen. So let's say print vertical. Else, let's just do return. Var, let's do y test. Let's change that to y test. And then we're going to do x test equals vector3 dot dot, and we're going to do vector3 dot right, comma collision dot, oof, what is that? Collision dot transform dot position dot normalized. Okay, and then we'll do print x test. Okay, so if we move vertically off the screen vertically, we'll see vertical. Otherwise, we'll see, if we move off the horizontal, we'll see, I think it's going to be 0, and that's going to be 1. So if we go move vertically, we see vertical, vertical, and then if we move off to the right, we see vertical. I really don't care about that dot product. So let me say, let me put that as 0.5f, actually 0.9f, so that we don't get any anomalies. It's got to be like straight vertically up. Okay. So we're going to do that, which is vertical, and this should also be vertical. No, 0.75. Yeah, this isn't going to work. Well, at least we know that's -1, so that's good. But if we do it higher up, do we still get the same values? -91, -93, -93. So you're definitely not going off the vertical screen there. Let me do how do we do this again? This is x test, comma y test. String interpolation there. So you just put a $sign at the start there, and then you can use these braces to add your variables, and you can have anything you want in there. You could do vector3 dot whatever expression, as long as it works out as something that's printable, you're good to go. In fact, I think you can even put an object in there, and it just puts in an object, which is not useful, but it's, you know, it converts it to a string. Okay, so at this point here, it is 0 and 1, which is right, and this should be 0 and -1, which is also right. Now, when we go down over here, it should be, so we're going off the rightmost one there, and it is that value there. I think I'm making this harder than it should be. Let me have a think. It helps if you use the right sign. I don't think that's the right one, so let me do that again. Oh dear. Cross. So this is going to give me this value here, And then I can do print x, y, z. And this is going to be test. So it's going to be test dot that dot y dot z. Okay. I looked up the cross product. Okay, so go up, 0, 0, 0, go down, 0, 0, 0. Well, that's not good. That way, 0, 0, negative 99, 0, 0, positive 99. Okay, so that is for those values there. But if I go up to here, okay, that's still 0. That's still 0. That's good. I go down here, that's still 0, and that's still 0. Okay. No, it's not any good. Damn it. Oh no, it is. It is. Well, I guess I don't care unless I go right off the edge there. So it's only 95, 96. So it's 90. 88. Okay, so if it is, so if test dot z is greater than 0, 0.88, print, actually that would be mathf test z, print horizontal. Okay. So press play again. All right, so go off the right hand side, horizontal, go off the top, shouldn't register. No, didn't register. Go off the top there. Go off the bottom. Okay, we're getting somewhere now. That's there. Okay. Perfect. Okay. Else, actually, let's just do return now. And so we can get rid of all of this. And then we can copy this. And we can do that. And instead of that, we're going to do right. And var vertical. I'm going to take that out. And I'm going to say print X. I have a new keyboard and I'm really not getting used to it. I might have to bring back the old one. But that's my issue. First world problems. Okay. So go off here and I get horizontal, go off here and I get vertical, which is 0.82, and then down here should be negative. Okay. And this should be negative as well. Awesome. Okay. So var direction equals mathf dot sign test.z if direction is less than 0. That means we want to say player.position plus equals, and then it's going to be the bounds of that. So I need to then say, where we got? We're going to have private box collider 2D collider void awake, because we're going to now need to get a hold of that. So we're going to say collider get component box collider 2D. So that there, and then we're going to say plus equals that dot extends collider dot bounds dot extends dot x times 2, I think. Why is it not like that? Oh, right, yeah. So I need to wrap that inside a vector, new vector 3, that comma 0. Okay, so and put that return there. So we check to see the direction. If the direction is less than 0, then actually we don't want to do that. We just want to say we don't need the if there. We just need this. So I'm going to calculate this as being var offset equals that times direction, whatever that is, and then I'm going to say offset here. So wherever the player is, they move to the other opposite side of the map. When they go off that end there, they'll come off the left end. So there we go. Perfect. Okay. So that is the left and right done. So now we need to do the top and bottom. So when they come off there, they'll end up over there. Perfect. Okay. And so we need to do the exact same thing for this one. So we're going to change that there, take that out there, change that to vertical, blah, 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 and that's going to be Y, and then this is going to be 0, and this is going to be offset, and I don't need a return because it already does that, and I don't know why I'm talking like this. And vertical, let's change that to horizontal. And we'll take that out there, take that out there, and that is that. Okay. What I might do is wrap these in helper classes. Okay, so we go up the screen. Oh, I might have it opposite. So that would be negative, because the screen's effectively upside down. Because Y is vertically that way, but it actually goes that way. If that makes any sense. There we go. Perfect. Okay, and this is going to work. We might need to tweak it for whatever size we get for the camera, but yeah, that's the wrap part of it done, and it works with all of the pickups and everything as well because it is attached to the player. If I can remember how to. It's not working. Whoa. Oh, that's a bug. Well, we'll figure that out later on. We still have a pickup ticket to do anyway. Uh-oh. That didn't work. Oh yeah, because it's got to be greater than 0 for the y, because it doesn't care what direction you are. Okay, so go back up there, and if we do it over here, should be the same thing. All right. Okay, I think that ticket is done. We should be able to go diagonally as well. Boom! Look at that. Works perfectly. Flawless. Let's go back the other way. Work diagonally. Perfect. Nice. Okay. So let's move that ticket to done. Thank you, cross product. Thank you, Unity scripting. That's my comments there. So that was wrap player on screen bounds. Boom, done. Okay, so the next thing is the room renderer. So the room renderer we need to do before we do the room change. What I'm going to do is I'm going to tidy up some code first. I think that we could have this inside a handler. So what I'm going to do is I'm going to say public, oh, it's going to be private. So if we enter exit a trigger, I'm just going to create a helper class. So I'm going to create add helpers, and then I'm going to have add class, and in this class I'm just going to call it player bounds detect, and I don't want that namespace. Bounds detect, so the collision is going to be whatever the player is, but we need to pass in this collider. So I'm going to have private read-only box collider 2D collider, and I'm going to pass in everything into here. So the collider's there, and I'm going to say private player bounds detect player bounds. Just call it that. Detect player bounds. Or actually, just call it the opposite of that. Just call it that. Take that out there. Change that from a capital P to a lower p. Okay. And then inside awake, I'm going to say that equals new player bounds detect. I'm going to pass in collider. And I'm going to say public player bounds detect box collider 2D. Collider equals collider. Public void handle event. Collider other. And I'm going to say if other dot tag is not equal to player, return. Otherwise, I'm going to do all of this. So I'm going to go and grab that, take this out of here, and put it in here, and I'm going to get some errors, obviously. So it doesn't like this collision, because this is actually this one here. So I'm going to change that to that, change that from there to there. And then the player position is going to get passed in as well. So I need to pass the player in as well. So I'm going to have private read-only transform player player. Okay, get rid of all of these. And now all I need to do is I need to say player bounds detect dot handle event collision. There you go. So I've reduced all of that to one line of code. Admittedly, everything else is now inside this other class, but this one class does that. And we can probably make that a bit more generic. It doesn't have to be player in there. So this is going to be player equals player, player. But this could be target, for example. So when the target leaves the bounds, change it there. So run this. It should be exactly the same. Here we go. No change. Okay. Perfect. Okay. So the next step now is to create, is to find out where the actual bounds are here, because I need to do that before I do the renderer. In order to do that, I am going to have to create something in Photoshop. So I'm going to go ahead and do that. I'm not going to record it, but basically it's going to be just a texture that I can stretch across the entire size of this just to get an idea of how big we have to go. Now, I will say that I don't mind the vertical thing, so I don't mind any vertical bleed, but I want the right-hand side edges to match up perfectly. The vertical bleed I don't mind because it could be just slightly over there on the top and slightly under there on the bottom. I'm fine with that, but they have to be crisp right on the edge there, just to make the game fit in 16:9. I might have to change some values. So anyway, I'm going to go do that, and I'm going to come back, and you'll see the image that I created. And I'll do that right now. All right, so this is my. I just do to get the size of the screen. So if I go into here, just to be open, transparent, honest, all that kind of stuff. The pixels per unit for this is 8, and that's the same as the player, same as the keys. All of these are 8 pixels per unit. But what I've noticed is that I completely went way too big. This is the actual what the player would see. So when you play the game, you see that it's the bounds are way off. So I'm going to drag the camera down so that it covers most of this. And it should, I don't want the bounds to go over on the right hand side. So that's 10.7. So 10. 11 is too big. 10.5. No. Which is there. Okay. So that is the right size for it. So I don't mind the bottom one. I don't mind the bottom one being cut off. I can live with that. But I can't have the top one being cut off. So this is exactly, let me get a calculator, 304 pixels by 171 pixels. It's 16 by 9 it works out as. So if you do 304 divided by 8, you end up with 38. So there are 38 blocks along, and there are 171 divided by whatever that is, divided by 8, which is 21.375, which is about right. So yeah, so we'll call it an even 22 when we make it. I'm going to use tiled, and I'm going to go with that. I'm going to go use that application, and then we're going to do the renderer for that. So we need to bring in the screen bounds as well. So if we go back to here, we'll see that the screen bounds are way too big. So if we bring these ones in, to about here-ish. So they're roughly just about just smaller than the screen itself. 28.9, 28, 20.9 even. There you go. Okay, that looks about right. So now when we play the game, so we're right bang slap in the center there, so it should just work for the bounds. There you go. So we don't need to change any code. Everything just works, and we can still do the diagonal thing as well. So we should be able to pick up the key and a sword and so on. Oh, something happened there. Well, I guess that that's an edge case. Is that we ended up way out of there on the diagonal, but we should get blocked off there anyway, so it shouldn't be an issue. So long as the majority of the cases work, like you're not going to get a point where you can actually go off on the diagonal anyway, so I'm not too bothered about that. All right, so next thing is the data and then the room renderer. Okay, so I'm going to create a folder in here called resources. Add folder. Oh, yeah, inside here called resources. And I'm going to use that to load the actual room data. And the first room I need to design is I need to design the castle room. So I'm going to go do that in, I need one block. That's all I need. And we're going to use colors in the renderer. I have it all in my head what I want to do. And we'll get to that when we do the implementation. But for now, I need to have blocks. So I'm going to go and I'm going to make a map inside tiled, and then we're going to import that map from tiled into here. So we'll do that right now. So I had a go at this earlier on. Here's the settings that I'm using. It's orthogonal, CSV. You can choose whatever one you want. I'm just going to choose CSV, which is comma separated values. The tile render order is from the left side down, so it starts off top left here, ends up bottom right down here, and it is 38 tiles by 22 tiles, and that's the width there, and the width of each tile is 8 pixels. So I'm going to click on OK, and that's going to give me this size here, and I can zoom in just by using the Control plus keys. This is tiled, by the way, if you've never seen it before. I'm going to add a new tile set, and the new tile set is very, very basic. It is, in fact, where are we? Based on this location here. So I'm going to go grab that. And go into tiled, and I have a block here. And I'm going to click on OK. And the block is just a hidden pixel almost. And the first room that you appear in is actually the castle room. So it has a block of 3 pixels up here that is visible. So you choose the stamp, and then you can just draw on here. I don't know why it's not drawing. I think it's not drawing because that is actually the only one and only pixel. Let me bring in another tile set. Show grid. Let me bin that. Yes. Okay. Browse, and then let me bring in Venture, Assets, Art. I don't know, blocks. All right, okay. Let me create the block, and I'll come back in here a sec. So I'm going to create this here, browse, I'm going to use blocks. Okay, so I'm going to have a couple of layers here. So the first one is I'm gonna draw the border around the screen, and that's going to allow us to encompass the player inside the screen. The second layer is going to be the visible layer. So the first one is the collision one. The second one is the visual, so the actual visual border of the layer. And the reason why I'm doing that is because if we take, do I have an example here? Yeah. So Atari Adventure, the first one that pops up, if I open up this new window, so the player is blocked from going through here until they get the key for the yellow castle or the gold castle. And so in order to get that, you've got to go and find it in another part of the map. When you get it, the portcullis opens, and then this here is available to you. You can go down to this point here, and it's blocked. So I need to have something similar to that as well. And so that's why I'm going to have a couple of layers, and then I'm going to turn them off and on, depending on what the player is carrying. So that's the idea anyway. So for the first one is this room here. So I'm going to choose, I'm going to start drawing this out just now. I'm going to fast forward it. I'm probably going to make some mistakes and things, but yeah, I'm going to draw that just now, and then we're going to come back, and then we'll fill in the rest of the stuff. So see you in a bit. Okay, so you don't have much room in the way vertically now, so but it's a good approximation. So here is the collision part. I'm just going to take this off here. So here's the collision part. So without anything else being rendered, the player is allowed to wander around these areas in the map. So they're not allowed to wander in any of the black areas there. Now, I want to block off something, so I'm going to create um, a way to do that. And the way I'm going to do that is I'm going to have an exclamation mark, and that's going to say not, and then you can't pass until you've got whatever the criteria is. So for each of the keys, I'm going to give them a name. So the yellow key is going to be yellow key, black key is going to be black key, white key is going to be white key. So if you don't have the yellow key, then this is going to be in place. So if you have the yellow key and you've touched this, maybe this is going to be, I'll need to figure something out for that, but we don't need to worry about that just now. I just need to do the rendering part of it. So this is going to be in place anyway, this part here. And then anything that's visual, so anything that's inside here, we're going to add collisions for. But anything here is going to actually be visible on the screen. It's going to be whatever color it is. Right now it's just yellow because that's the only color I have for this one here. So I'm going to save this inside the resources folder. So I'm going to grab this, and this is a TMZ file. So I'm going to go into tiled, and then I'm going to call this room 0. Save. And then I'm going to export this as well. So export as, and it exports it as a JSON file. And again, I'm going to go to Adventure, Assets, Resources, and then room0.json. So I'm going to click on Save, and that's going to save that. Now we need to read this into memory, and then draw it on the screen. And for that, we're going to go back to the code. Okay, so this is the format of the JSON file that tiled spits out. And so you see we've got height, we've got layers, we've got tile width, we've got version, all that kind of stuff. We know what the height is, we know what the layers are. We don't really need to know that. What we do need to know is this part here, which is our layer data. So this is the part that we're interested in. So we're going to write an importer that goes and grabs those files. It goes and grabs the content of this file and then gives us something back that we can then render to the screen. So that's the next part here. So we're back to Unity. So here is our resource here. So I'm going to create a script and I'm going to call this environment. And I'm going to call this one room loader, or actually let me call this room data. And room data is going to be a copy of this JSON format. So I'm going to double click that. It's not going to be a mono behavior. It's just going to be a plain old C# class. So what I need to do is I need to have, I'm just going to split the screen here just a little second here. So I need to have data, height, name, collision, opacity. I need to have all of these things in here. So I'm going to do, I'm going to mark this as serializable. System. And I'm going to have public int data, public int height, public string name. And this is going to take a little bit of time to do. So what I'm going to do instead is I'm going to show you a little bit quicker way. So I'm going to go to Sublime. So this is our Sublime editor over here. And I'm just going to grab those values there. Okay. So I'm using the middle mouse button here. And I'm going to copy it. And then I'm going to go back over to my Visual Studio. And I'm going to go back to room data. And I'm going to paste it in here. Now it looks a little bit of a mess, but we can tidy it up in no time. So first things first, we can do the whole Alt. Remember the rectangular section selection thing, so we can clean that up that way. We can then go to the end of the line and clean these ones up like that. That's fine. Opacity. That's fine. Height. Yeah, that's fine. And then data. And really what we want is we have height, width, visible, type we don't need, opacity we don't need, I mean visible we probably don't need either. So if we then go and use the rectangular selection again, we can then do public int height, public string name, public int data. And there you go. So that's all we need for the room data. And then we need to have another file. So that's the room data. Well, actually, that's going to be layer data, isn't it? Layer data. So let's change that to layer data. And then we can use control that there. And we'll change that to layer data. And then we'll have another file called room data. And room data. Oh, darn it. Room data is going to have public layers, layer data layers. That's going to be serializable as well. Okay, and that's all we need. We don't need anything else. We know everything we need to know. We just need to have that information on screen. We just need to know the tile data here. Okay, and then the loader. Let's have one here. Add class load data. Well, load. Actually, room loader. And we'll have public static room data load room name. We'll give ourselves a bit more room here. Talking of room. Terminal. Okay, and then so for this one here, we're going to do var text asset equals resources dot load text asset room name. Oh dear, that all went wrong, didn't it? And then we're going to say var room data equals JSON utility dot from JSON room data text asset dot text. Return room data. Boom. There we go. So that is our very, very super simple loader. I don't think we need to do anything else other than that. We've got our room asset. We want to do that there. We can also do it as public static room data load text asset, and just cut out the middleman and just have that there. So just in case we've got two ways to do it. We can load it in from the room name, or we can load it in from a text asset. In fact, what we could do is we could also do return load text asset. That there. So we're not duplicating code. We're just doing this as a courtesy one there. So that's that one there. And then we need to have our room renderer. So let's go back to Unity and do the proper way here. So that's environment. I'm going to create, I don't want a folder, darn it. Yeah, get rid of that. Create C# script room renderer. And room renderer is going to have our room loader. But we also need to know, so inside our art, do we have a, okay, we have player, which is the block as well. So we need a prefab for each block. So for now, I'm just going to use the player, but we'll need to change that up a little bit. Public game object block prefab. Public text asset. I mean, we probably just want rooms. Do we want this in the, do we want something that's pure, that we specify the room and then it goes away and does it? Or do we want to have, let's do pure. Let's do pure. Okay. So I want to have a public void render room and then we're going to pass in a text asset. Okay, or that would be asset. Var room equals room loader dot load asset, and that means that our game controller now has to have public text asset rooms. So this now has to have a list of all our rooms, and our rooms are stored inside resources. So where are we? This is game object. Let's rename that one. Game controller, and drag that right up to the top there. So inside here we have rooms, which is nothing. So this is going to be an array of rooms for a start. So we have rooms up here. So we're just going to drag the first room over there, that one there. And so when it starts, we need to have a reference to the renderer. So now we need public room renderer, and we need to drag that in there. So our game controller, I'm going to put the room renderer on here anyway. Why not? We'll add the block prefab, which is going to be the player just now. Oh, it doesn't let you do that because that's not a prefab. Let me just drag that in there, and I'm going to call this block prefab. I'll just call it block. We know it's a prefab. And then create prefabs environment, and I'm going to drag that block into there, delete it from the scene, and then drag the prefab into there. So now we have a prefab loader. Okay, and when we do void start, we're going to do renderer dot render rooms 0. So we're going to pass in our room to the room renderer, and then the room renderer is then going to render the room. So that's good. And in room renderer, we are going to do for var y equals 0, y less than 22, y plus plus, for var x less than 0, x less than 38, x plus plus. What is going on here? X plus plus. I don't know what's going on. Okay. So we're going to go from we could change them to max and min values, or we could change them to constants. I'm not going to do that just now. But we only want to render the visual portion of it just now. So I mean, if I well, okay. So let me do room loader load. Let me do something in room data. So data is going to the layer data. I want to get information about about that part there. So I want to say public bool is is set int x int y, and I want to say var index equals, and then this is going to be y times 38 plus x. Return data index greater not equal to 0. So I just want to check to see if it's set, and if it is set, then I want to do something with it. So bearing in mind that our tiled, we have a collision, we also have a visual. So our collision is there, but we also need to have colors as well. So in our renderer, public color room colors. Okay. Sorry, I'm jumping about a little bit here, and I realize that. But our room colors, we have, how many room colors do we have? I just closed that in. No, I didn't. Here we go. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 colors. So I'm going to change that to be 8. And I wonder if I can get this. I wonder if I can choose this from over here. Make it a little bit easier for me. Boom. Okay. So I'm going to choose these colors here. I'm just choosing, you can choose anywhere on the screen. It just so happens that I'm choosing this off screen because it makes it a little bit easier for me to see. And then the final one, that one there is black. So I'm going to do that one there. Okay. So when we render a room, what we actually want to do is we want to pass in int room color. So we want to pass in room color, which is going to be, we're going to default it to 0, which is that yellow color. So we're going to say var collision equals room dot get layer get collision dot is set xy var block equals room dot get what did I call that? Oh dear, memory like a sieve, right enough. Visual. XY. Okay. So if I go to the room data here, I can say public layer data get visual return layers dot first. Actually, can I do first? And then I can pass in layer data d dot name equals visual. Just makes it a little bit easier. It's probably quite slow, but it should be fine. Get collision, and we'll change that to collision as well. Collision visual. Okay. So we're using link, which is this handy dandy additional functionality that goes through. It basically does for each layer in this, go through, check to see if the layer name equals visual. If it does, then return the first value back to there, and then that returns just that one copy. If it doesn't, it just returns the default. We know there's a visual, we know there's a collision. I'm always going to have visual, I'm always going to have collision. So I'm not worried about that bit there either. And so it just makes it a little bit easier to figure out inside the room renderer if something's being set. So we can say if block block copy actually I need to know what the start is, start and offset is. So var pause equals new vector 3D. So I just want it to be pause, and oh, this is going to be offset. So if there's a block here, I want to draw a block at the new position. So I want to say var pause equals offset plus new vector 3 x y. Because remember, each one is a unit, so it will draw each one of these. So if it's a block, I want to draw that block. Okay. But I want to know the color. So I'm going to say var copy equals instantiate block prefab. I did not put an underscore there. Oops. And I can specify the position as well. Vector 3 position, which is going to be pause, returning dot identity, because we don't have any thing there, and we do var sprite equals copy dot get component sprite renderer color equals, and then it's going to be room colors, room color. So we're gonna color it whatever the color is, and that's all we're gonna do just now at this very second, because let's run it and see what we've got so far. So we're not using collision just now, but the collision we need to figure that out. Actually, we can just turn that on, so we can say we'll turn that on. Okay, so let's get rid of this test card, so we can get rid of that. Let's move the player down just a little bit to about here. -7, -8. So down to 8. Let's get rid of the sword and the pickup. Actually, let's move down to prefabs. So we'll create a folder here called objects. I'll call it sword, black key. We'll drag them into black key, sword. Okay. We'll get rid of that just now. Delete. Alright. So do we have anything missing in here? Nope, we've got that one there, room 0. Okay, so we click on press play. And we get null reference. Alright, good to go. So the null reference is at here, which is the renderer, which we haven't set for some reason. I thought we had. Oh, that's right, because we need to drag it into there. So we need to drag in this object in here into the room renderer, because it's on the same game object. It's just a component. I could have done the get thing, but okay. So we got block clone. So let's go to scene. Well, I don't see anything. Well, it has rendered it. Oh, the alpha is 0. Well, that's just weird. Okay. Well, that means that the alpha is 0 for all of these. How the heck did I not see that? Okay. Okay, let's try that again. Okay, it's going to be way off, but hopefully we should see something. Oh, it's way off. It's upside down as well. Okay, well that's promising. Okay, what we should do is we should change that. Where are we? That should be negative. Off. It should be offset minus that because we're going down the screen. Okay, so that's the right way around. Now we just need to get the offset, and we also need to have that in the background as well. So I'm going to go to where's our prefabs? Environmental prefabs there, and then there should be a order and layer. I'm going to change that to -50 because it should be in the back. It shouldn't be overlapping anyway, but the player should be on top of it, so to speak. Okay, and now we need to get the offset. So it's currently 0, 0, 0 is down here. So we need to mark it as being the extent of the screen. So that means we need to do that's going to be 19, I guess, and then this is going to be -11. Would be my super duper guess. Actually, it would be 11, wouldn't it? Because that's the top part of the screen. So this should fix everything. Boom, there we go. All right, it's starting to look good. We have a castle. We need to bring that down just a little bit. So that's going to be 10.8 maybe. We should probably expose these values. All right, okay, that looks good. Yeah, you can move around the screen. Okay, and you come out the other end. Sweet. Okay. Nice. Okay, so that render is working. Let's see what we got here. So we're a little bit too high on the Y. So what if we made that 10? That should bring it down a little bit. Uh, 10.1. Just want to nudge it, get it right. 10.2. Getting there. This one for sure. Okay, that looks good. Oh, that is right on the money. Oh yeah, could have planned that. Okay. So now we need collisions. So the collisions, we want to add a collision on there. So we want to say if collision copy.add component box collider 2D. Var collider equals that, and then collider type. Oops. What do we call this? This is I think that's okay. So if we get a collision, then we want to add it to that object. We also want to get rid of all the other objects. We need to have like some kind of, I mean, we should have some kind of memory management, but oh, this is no good. It does add a box collider. Okay. Hold on. Okay. It's not a trigger, but the player does a rigid body against them. Yeah. That's a rigid body 2D. Later. Okay, so I was reading the docs, and I think it's because, well, I don't think I know it's because the box collider here I have for, sorry, my rigid body here is kinematic, and the player movement, the locomotion, it does transform.position to there, and I think what it should do is it should move to that position. So I'm going to create vector variable offset equals new vector 30, and then I'm going to say offset plus equals that, offset plus equals that. So I want to add, oh, new vector 3. And then I want to do get component rigid body 2D, move position, and then I want to specify the new position, so I better change that to 2. There, and there. Transform.position plus offset times time dot delta time. Is that how they're doing it here? How are they doing it here? Of course, this is in 2D. Of course, I can't get that there, so I need to do var pos equals new vector 2 x dot y, and then it's going to be pause. So let's see how this breaks movement, because according to this, setting the transformation position doesn't do any interpolation, so it doesn't check any collisions. Okay, well that's moving very slowly. Let's see if it blocks it. No, still not blocking it. Well, I guess I'm already doing time.delta time, so I don't need to do that. That's being handled up there. So that might make it move a little bit faster. I still don't see why it's not blocking that. Okay. Well, that's, I mean, that's okay. I don't mind. Okay. but it's still not blocking the collision, which is what I want it to block. So each one of these has a collision on it, and that's not being detected here. So how to prevent kinematic rigid body? It's not a problem. You move. How are you moving the boxes? You should trigger the object touch the walls. I mean, what if the player was dynamic and we freeze the rotation on there, on the Z. Gravity scale, let's do 0, which gravity affects the body. Okay, so now it's fully dynamic. This will work. Will it hell? Oh, no, it worked there. Oh, I guess it won't work there. Ah, no, it is working. Oh, wait a minute. Oh, it's not working there because I guess that doesn't have... I don't have collision data there? Oh, that's just weird. Okay. Alright, okay. Maybe it's sticky there. Okay. Well, I'm stuck up there. Well, that's okay because you can't get past that bit there. Actually, let me let me change some of this. So the visual is that. So if I change that so that it can only come out here, I think that's fine. I mean, it kind of matches up with that one, so I can get rid of that there. So it can't fall through there. And then the collision part of that, does that match up? Yeah, see the visual there doesn't match up with the collision, which is why I was getting the overlap there. So I'm going to add the collision. Here. Oh, it helps when I'm doing it in the right place. There. So that should match there. Okay. So save that, and I will export it to there. Click on there. Yep. And now we run it. That should have fixed that problem. Aha, see, it's going to let me go through there because yeah, okay. See, we've got a block there. Okay. And going through here, we got a block there. Okay. Sweet. Okay. And that's using yellow. So if I change that to purple, where are we? That would be game controller. So if I choose that as room 0 and then choose a different color, the second color, which is that green color. When we run it now, we should get a green castle. Boom, there we go. Now we also need to change the player sprite as well. So, yeah, we need to know about that as well. So maybe we need to move that to another class. Okay, let me see what we got here. So, what do we do today? We've done in progress room renderer. Okay, we haven't done room change, find screen bounds to determine map size. Oh, we did that. Let's move that over to here. Okay, so we're still working on the room renderer and we still need to do the room change. Okay, in the interest of saving time, I will do I'll do the next map section. So we need to do Atari Adventure map. And there are 3 versions of the map, I think. Depending on the levels of the map. Yeah, this is it here. Okay. Okay, so unlocking adventure. Adventure is created an Easter egg, blah, 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 blah. So this is what we need to build. We need to build this map here. Now, if you are in depending on the mode that you're in, you're going to get more or less of these things. So in the first player mode, in the game 1, so there's 3 skills. There's hard, normal, medium, and hard. So the first one is very, very basic. It's just this part here. I think there's just this screen here, and then there's this bit here, and then that takes you to here, and then there's a room here, but there's nothing beyond that. So we need to build the ones for the different skills, and that's what I'm going to do just now. So I'm going to create these objects here. So there's this room here, which is repeated 1, 2, 3, 4 X number of times, and then there's this room here, which is repeated X number of times as well. So this one here, this one here, and so on. So I'm going to do those just now, and then we are going to come back, and then we're going to set up a map information, and then yeah, we're going to get this game going. It crashed. Is I'm going to rename this castle, because all the castles look exactly the same. So I'm going to do file, save as, castle, and this will make it easier to identify what the files are. And then I'm going to export that as castle as well. So no longer room 0, it's going to be castle. So I'm going to go back into here. I don't want that. And I'm going to change this over just now. So get rid of this one. And this one, I'm going to change that to castle. Okay, and I'm going to get rid of room 0. Yep. And just run it and make sure it works okay. Yeah, worked a treat. There you go. No errors whatsoever. Darn it. Oh, come on. Open. Room 0. Where are these coming from? Oh, that's not even the right ones. That's why. File, open. Pixie Atari Adventure, room source. That's not the, no, that's not the right one. Helps we get the right one. They modified Atari Adventure, tiled. Oh, they're in there already. Okay, so let me get castle here. So my machine, like I said, my machine crashed, so let me just save that as there. So export as, and I'm going to change it to castle. Click on there, click on save. Okay, ignore me. This will work now. Boom, there you go. So we got a nice green castle there because we chose the green color. Okay, so now what I'm going to do is I'm going to take all these. I'm going to have like a exit top, exit bottom, that kind of thing. So I'm going to do that just now. I'm going to speed this up so you won't have to watch me creating it. But that's what I'm going to do is create all these separate rooms, and then I'm going to put them all together inside the map. So I've done all the screens. Now we need to create map data. So I'm going to go ahead and do that. All it's going to be is I'm going to take these values here and then say, okay, so this one, these two here are like room 0, for example. So that's the 0th room. So this, or the 0th room shape. So this one leads on to this one leads on to this one, and I'm just going to create map data for that. And then I'll explain I'm going to use JSON, and then I'm going to explain the JSON format after I've done it. But it's going to take a bit of time, so rather than me trying to figure it out and talk about it while I'm doing it, or not talk about it, which is even worse, I'm going to do it offline, and then I'm going to come back and explain how I've mapped everything up. The most obvious choice is probably a scriptable object, but I'm going to go with a JSON file. Old school, reliable. Assets, resources, explorer dot. Okay, so I'm going to create a new file in here, and I'm going to call this normal .json. Yep, and I'm going to open this with Sublime Edit, and I'm going to create a JSON object. A JSON object is just a simple text file, and it describes the properties of your object that you want to create. And it's a really super lightweight, basically key value pair. So you have a string, so you've got name, Sloan. There you go. So there's the first object. So the first object has a property called name, and its value is Sloan. That's it. And then you just separate them with commas, and then that's you're done. So what do we want to contain in here? Well, I've got a little note here that I wrote. There you go, on my failed printout. And then I looked for a bit of paper and I couldn't find a bit of paper, and I was like, all right, okay, well, so I retrieved this from the trash. Anyway, waste not, want not. So in there is my little note, which doesn't mean a lot, but it means something to me. So I want to have a room, and then inside that room I want to describe the shape that it's going to have, and also the color that it's going to have. So I'm going to have shape 0, color is also going to be an index value, and then exits. So the exits are going to be north, south, east, and west. So we're going to have north, south, east, and west. So those are going to be the exits for now, because we're going to get a little bit of a tricky situation when we get to, I'll show you in this map actually, rather than this map. This map here, so you'll see that you've got these letters here, so C goes to C, D goes to D, so that should be okay, actually that should be okay. The only problem is that, oh no, that should be okay actually. Yeah, I think north, south, east, west we can get away with, because AB goes to here. Yeah, I think we should be fine, because everything else is blocked off. So yeah, I was worried about something else. Anyway, and then for an exit that we don't have, we just do -1, and then that means that there's no exit there. So this is our first room, but each room is part of a larger object. So our larger object is rooms, and that is an array. An array is denoted by square brackets. And so that is our first room. And I think I can do format document. Oh, no, I can't. Install package control. Let me see if I can get. Yay. Okay. Package. Okay. I want to have a JSON formatter. JSON lint. There we go. Did it install JSON lint? sets to JSON, JSON. Oh, it's just a linter. I need a formatter. Formatter. Yes, lint Lua. Pretty JSON. There we go. Did that install it? Pretty JSON. There we go. JSON is valid. Okay. Format and sort. There you go. Boom. That's the word I was looking for. That took a while. Okay, so each one of these is now going to be a room, and we're going to describe those rooms. I'm going to need to go back to the map, which I'm going to have to put on this side of the monitor here. And I'll put this here. So I'm going to describe the first section here. So this is going to be room 0, 1, 2, 3, 4. Okay, so that's 1, 2, 3, 4, 5 rooms. So I'll go 1, 2, 3, 4, 5. So that is our 5 rooms there. The color is based on the colors in here. So 0, 1, 2, 3. Oops, sorry, this is out of. Sorry, let me just bring this up here. So this is color 0, 1, 2, 3, 4, and so on. So the colors of the rooms are. I'll move this at the road a wee sec. So the 0 and 1, and then 2 is that drab olive color. So that is 2. And fascinating stuff, this I know. And then we have 7, which is 0, 1, 2, 3, which is 7. And then the other one is, it's a bright yellow, but I'm going to make it the same yellow as that one there. So that is going to be 7 as well. Okay, and then the next ones, the room renderers, we're going to have, we have our rooms here. So I'm going to drag in all our other rooms. So we have castle, but we have all these other rooms here. Oh yeah, normal's there. So we need to drag in all of those. So I'm going to freeze this. I'm going to lock that in place, and I'm going to select all of these. So these are all the rooms. It doesn't matter what order they're in, so long as we know what they're in. And then we're going to do that there. And so our first room, so this is our room shapes now. So our first room shape is the castle. So that's fine. So we have castle shape there. That's okay. And then the next shape is exit bottom, which is 1. So we change that to 1. Hope everyone's following this at home. Hope it makes sense. So this, let me just put this over here. So our next shape, so this here is room 0. This is room 1, 2, 3, 4. Okay. So we have our first room here, which is the castle. The second room here, which is the room above that. And then we need this one here, which is the room with exits on the top and the sides, which is going to be exits, top, sides, which is element 6. So this is going to be element 6. And then the one beside that is also element 6. And the one beside that is element bottom and sides. So that's bottom and sides, which is element 2. So the last window there is 2. Okay. Now we need to determine what direction each room goes to. So for this room here, we have exits top and bottom. So our north goes to room 1, east goes to -1, and west goes to -1. And then south goes to 0, 1, 2, 3. Okay, and that's us done that room there. And in this room here, we only have a south exit, and the south exit takes us to 0, so everything else is -1. Okay, I'm going to keep doing this, and I'll finish off this JSON file. So now everything is in here. We need to now do the same thing that we did for our scripts before. So we need to create new data objects. So our environment is inside here, and I think we'll just continue to put it in. Yeah, let's put it in here. So let's create this. What do we have? So we have so let's call this map room data. Yeah. So we'll call that map room data, and then we'll call this level data. Okay. I don't know why it's coming up with this CS error. I haven't actually typed in anything yet. Oh, okay. That's just weird. Why did it do that? Level data.cs. Map data.cs. Okay, so maprim data.cs. It doesn't need that, and it doesn't need that. What it does need though is it needs all these things here. So these are all integer values, so this makes it a lot easier. So I'm going to do the exact same thing that I did before. Oops, what is going on? Which is go grab those values there, and off there, there. And then have public int color shape north, south, east, west. That there. Using system. Serializable. So that's the map room data, and then the level data is not mono behavior, but it is also system. Get rid of that, and we say public map room data rooms. Serializable, and room data. So we want to have probably helper functions in there, but we'll leave it for just now. And I'm going to do add, and then this is going to be level data. What do we just call it? Loader. Level loader. Public static class. Actually, I just need a static class. Public level data, load level, and then this is going to be text asset level data, bar JSON equals level data dot text return JSON utility dot from JSON level data JSON. Okay. And that will load the level data for the game. All right. So for, what do we have? Our game controller, we need to have levels. So we're going to have public level data difficulty. So those are difficulty levels. Obviously, we're only going to choose the first difficulty level, but we still have to have one. And then inside our resources, we're going to drag, oh, that padlock's still on. We're going to drag normal into the difficulty mode. So the first difficulty mode is going to be, oh, what's going on here? Difficulty level data. Oh, it's going to be text asset, that's why. Oh, there we go. So normal level difficulty. So the way we can do that is when we start it, we're going to say, so the first room that you always start in is going to be room 0, no matter where you are. I think it always starts at the yellow castle anyway. So we're going to do var level data. Actually, I can just do, I might want to keep level data, so I'm going to have private level data current level, and I'm going to say current level equals level loader dot load level difficulty 0. Just kind of hard code it to 0 just now. Apologies for everyone. And then we want to render the first room of the level. So I want to say var room first room equals rooms current level dot rooms 0 dot shape, and take that out there. And I want to say var color equals rooms current dot rooms 0 dot color. Except that's not that, is it? We need to figure that one out. Oh no, we don't, because we just passed that in as the color there. Okay. So the net result of all of this is we should still see a yellow castle. That's the net result. And we do, and that's good. So right now nothing, it works exactly the same. Well, we can't go that way, but we can move up and down. So how are we going to detect that this happened, that this went off the screen? Well, what I'm going to do is I am going to add event handlers for this. So inside environment, did we put this inside environment? Oh no, we did it in helper. So I'm going to add class, and I'm going to call this direction. Public num direction, and it's going to be none, north, south, east, west. Get rid of that. Get rid of that. Okay, so we have none, north, south, east, west, then handle event, and then inside event, I want to see where the player went. So if they've moved out of here, I want to see where they moved out of here. So I'm going to create another event here, and this is going to be the player left the screen event. And I'm going to say public delegate void object sender player left the screen event args. Can't really fit that all in one screen, sorry. Public class event args public player left the screen event args direction, and I'll say public direction get direction equals direction. Ugh. Boom. Okay. Those there. All right. So the player left the screen event. So this is going to fire anytime the player leaves the screen, and when they leave the screen, we need to move into the next screen. So I'm going to create a event handler inside the game controller. So this is going to be, oh no, I need to create that first of all. Hang on a minute. So inside here, the player bounds detect. I just pressed there. Inside here, I'm going to have public event player left screen event player left the screen, and for this one here I need to determine what way they went. So if the direction is that way, they went right, so that means they went east, otherwise they went west, and then for this one it's north and south. So I'm going to say var direction equals compass equals direction greater than 0, direction dot east, direction dot west, and then dot invoke this new player event args compass. There we go. Again, it's slightly off the screen there. So yeah, so you can see that there. So this this here just means that if this is not null, then call it, invoke it, call the delegate, so whatever you've attached to it. And it's going to pass in the direction. And then we need to do the same thing for this one here, which is going to be north and south. So if the direction is greater than 0, then they're traveling north. Otherwise, they're traveling south. So inside here, I'm going to have player on the screen, handle player leaves playfield. And of course, we don't have that method, so I'm going to create that method, and then I'm going to say print e.direction. And so when we leave the screen, it's going to give us the direction to where we want to go. So hopefully it will be the right direction. Obviously I can only test north and south so far because I've only got this one here. So bring up console. So that says north, which is wrong, and then this is going to say south. Okay, well, clearly I got my compass directions wrong for this one. So that is going to be south, north. The other one's going to be fine. And now that we know the directions are, we need to figure out where we can go then. So we can say if let me do that in if current level. I need to know the room as well, don't I? Need to know the current room. Current room is that. Rooms. That's the shape. I need to know that. Current level room 0, but I do need to know the index value of it. So that's going to be private int room index equals 0, which is what it's going to be. 0 and 0. Okay. So for here, when I leave the playing field, we need to know the room. So there's that there. That there. I don't need to know the color. So with the room, I need to know if they can go in that direction. So if e dot direction equals, I'm gonna make this easy on myself. Not sure I can. North and first room dot. No. Actually, that's just gonna be room, isn't it? Is greater than or equal to 0. Change room. Okay. So I'm going to take this out here. And I'm going to say change room there. Room index. I'm going to have private void change room int room index. And this is going to be a nice little routine that is going to take the current level, the room ID, and then render that room. Now, when we render the room, we need to do a cleanup as well. So we need to do that. We need to do that now, I think. 12. List game object blocks equals new blocks, and we're going to say blocks dot add copy, and then at the very top here we're going to say blocks dot for each destroy b, So we're going to clear up, when we render a new room, we're going to clear up the old room. It's a little bit tacky, but it'll work. So we're going to change room there. And then we need to do the same thing for each one of these ones here. So we do else if e.direction equals direction.south and room.south greater than or equal to 0. Change room, room.s. Else if e.direction equals direction.west and room.west greater than or equal to 0. Change room, room.west. Else if e.direction equals direction.east and room.east greater than or equal to 0. Change room, room.east. And we'll tidy that up like that. Okay, moment of truth. So we head down. Oh, there we go. Take them out here. Something not quite right. Is that moved offset or something? It seems that the offset for that's moved. I see room renderer. The collections there as well. Something not quite right with the way that ends there. So if we go up to the top there, that should take us into here. Oh, it's not taking us to the right place. That's why everything seems to be going to this thing here. Ladies and gentlemen, I think we have something. Okay. So something's not quite right with this. So the exit is from here to the south is 0, 1, 2, 3. Okay, I think I might need to map this out. I think the data might be wrong, but the rooms are changing. That's a good thing. I'm going to check the logic and make sure that everything's running there okay. Yeah, see, that's not. So that room there is room 1. So room 1 is this one here, and south should take me down to room 0. Oh, do you know why? I know why. Because after this we need to say current. Oh no, that doesn't matter, does it? No, it does, because when you change the room, it needs to change the current room. Yeah, it needs to change the current room, that's why. Okay, so we're going to say room index equals room index. So the very last thing is we need to set the room index to be that. Or in fact, let's set the room index to be that at the start. And then we use room index everywhere. Because when you change the room, when it comes back in here, you're checking to see what room you moved to. So maybe the data is right. I think the data might be right. Just that little bit of crazy logic. So if we go up here, that takes you there, back down to the castle, to that drab place, to the other drab place. So we go back to the drab place, then we go up here, we should get to, no, next one. Oh yeah, it's not going to like that. Okay, where's the map? dusty map. Oh, that doesn't work. Okay, so we should go down to there, along to there, and then there isn't one there. Okay, that's why. So it should be down to here, along to... No, that's not right, is it? That should be... So that's right. And then when it goes... So that is room 0, 1, 2, 3. So room 3. 0, 1, 2, 0, 1, 2, 3. So when you go west, you go to 2, north to 0. Okay, so north to 0 should take you back up there. So that takes you to there, that takes you to there, that takes you to there. That's right. Okay, so all of that is right. That is correct. But when I go to 0, 1, 2, 3, 0, 1, 2, 3. When I go west, that should take me to 0, 2. And it does take me to 2. But 2 here, 0, 1, 2, is shape 6, which is exit top and sides. So why is that bottom and sides? I think I've got that around the wrong way. Anyway, the map is changing. That's the main thing. One thing I do want to change though is that block. The block should actually be above the player. I just realized, because then you go underneath the castle. So if I go to prefabs here, environment block, and then change this from negative 50 to positive 50, and then run the game. When you go underneath the castle, there you go. That's perfect. Okay, so now we're going under the castle. Yeah, that's... Oh, do you know what it is? Do you know what it is? I know what it is. I figured it out. I have got this mixed up round the wrong way again, because I said that would be right, and of course I was wrong. It was not right, it was wrong. So if we go down here and then we go this way, we should get to the yellow one. Yep. And then this way it should take us to that one and that one and then that one and that one. That one there, that one there, that one there, and then that gets stuck obviously because you can't actually go that way. Perfect. Okay, I think we'll stop that there. That's I think we've done everything we need to do. Let me check off and see what we've got here. So we've done the room change, done the room renderer. We haven't fixed that yet. Let me think about that. So we have our room renderer. Actually, let's leave that for another time. In fact, I think I can get rid of that just in here. No, I can't. Yeah, let's get rid of that one there. So fix player cooldown. Okay, so what do we get done today? We got wrap player on screen bounds. We got find screen bounds to determine map size. We did the room change. We did the room renderer. I think that's good going. That's a good solid video. Well, okay, I think it's a good solid video. Let me know what you think. Thumbs up if you liked the video, thumbs down if you didn't like the video. If you didn't like the video, please leave a comment below in the comments. Don't forget you can get access to the source code. It's all on GitHub, and links for that are in the show notes below as well. And as usual, thank you very much for watching. I know everyone's time is valuable, and I'm glad that you can spend a couple of hours watching me going and trying to figure my way out of this. Some people like it. Anyway, thank you again, and I will catch you in the next video. Bye bye.